Hello everyone and welcome back to physics class. Today we're going to be learning about vectors. So a vector, by the standard definition, is a quantity that has a direction and a magnitude. So just having the definition, it's a little hard to really understand what I mean. So I'm going to give you a quick example. So if we have this car, and the car is traveling east. And let's say that it's traveling at a speed of 100 kilometers per hour. When we consider the speed and the direction, we're now talking about velocity, which is a vector. So velocity is just speed with a direction. So vectors are especially useful when we're talking about movement and when we're talking about forces. And those are the two things that we're going to focus on in this course. You can have vectors in 2 dimensions and you can have them in 3 dimensions. We're going to be focusing on 2-dimensional vectors. Some people use vectors every day in their day-to-day lives. They might be an engineer who's designing a building to withstand wind or earthquake forces. They might be an air traffic control where they have to monitor planes landing and leaving an airport and make sure that none of them crash into each other. It could be an astrophysicist studying the orbits of different planetary systems in different galaxies. It could be a computer programmer. Could be a video game developer. Could be a graphic designer. All these people use vectors in their day-to-day lives. Now, let's go back to the definition. A vector is a quantity that has a magnitude as well as a direction. So vectors are made up of 2 parts. First one is the magnitude. This is the size of your vector. Then we have the direction. Now, we're going to be measuring direction in angles with reference to the positive x-axis. And we'll also use compass directions occasionally. So that would be like north, south, east, west, that kind of stuff. So let's take a look at an example. So I have this arrow here, and this arrow represents my vector. Now, the length of this arrow, I'm saying, is 5 meters. This angle right here, because this arrow is on an angle, I'm going to say that it is 30 degrees. So right away, I can identify my magnitude, the size of the vector. This is my magnitude. And I have to include the units there. And this right here is my direction. I can identify that because it has a degree, it's an angle. Let's take a look at a second example. This time it's going to be on a Cartesian graph. So I have an arrow here and it has a length of 10 kilometers and we have this angle in here that measures 35 degrees. Now, I can identify my magnitude very easily. Again, the size of my arrow is my magnitude. But identifying the angle is going to be a little bit trickier, because remember, we have to refer to the positive x-axis. So we have to start from this point right here. And then we would measure the angle counterclockwise like this. So our direction is not going to be 35. It's going to be 180, because this line here is 180 degrees. It's going to be 180 plus 35, which will give me a direction of 215 degrees. So this is my direction. So let's take a look at another example. Again, it's on a Cartesian plane, but this time my vector is pointing up and towards the left a little bit. Now, my length for this is 5.6 centimeters, and this angle in here measures 61 degrees. So this is my magnitude, and I'm just going to write MAG to denote magnitude. However, this right here, this 61 degrees, is not going to be my direction. Remember, we have to start from the positive x-axis and then we go counterclockwise. So I actually want this angle in here. Now to find this angle, I know that this line right here, this full line right here, is 180 degrees. So to find my direction, I'm going to do 180, and I'm going to subtract this 61. When I do that, I'm going to get my direction is 119 degrees. Now I want you to try this yourself. I'm going to give you a Cartesian plane with a vector on it, and I want you to tell me what is the magnitude and what is the direction. So we have this vector right here, and it is 75 newtons, and we know that this angle in here is 27 degrees. So take some time, pause the video here, try this out. Excellent. So we know that this right here is our magnitude. However, this right here is not our direction. Remember, we have to measure with respect to the positive x-axis, and we have to go counterclockwise. So we need to go all the way around from here to here. Now, this is almost a complete circle, but it's not quite. So to find my direction, I'm actually going to take my total angle for a circle, which is 360, and I'm going to subtract 27 from it. And when I do that, I should get 333 degrees, which would then be my direction.